This is my beginning algebra course. Today we're going to continue with applications of algebra. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. I want to mention again that we can't cover every single type of word problem that's out there because this course would be 10 times the size, and the purpose of this course is not to teach you word problems. The purpose is to teach you fluency in algebra. But the more word problems we do, the more it's going to take away your focus from fluency in algebra, and that's partly because the word problems are so intimidating. So what's going to end up happening is you're going to spend 90% of your time worrying about the word problems rather than worrying about the objective of the course, which is fluency in algebra. So we don't have time to or the energy to cover all the different types of word problems. You're going to learn more word problems when you start to study for competitive tests. So we're just going to cover 4 or 5 more types of word problems today, and then we're going to be close to wrapping up this course. Let's start with some geometry problems. The perimeter of the rectangle below is 98 inches. Find the length of each side. Now, you learned perimeter in my arithmetic course, or you should have learned it by now. Perimeter is one of those things that you're not allowed to forget in the math curriculum. If you forget perimeter, if you forget what perimeter means, that's like forgetting how to tie your shoelaces, or forgetting how to put your clothes on, or forgetting how to eat, or forgetting how to walk. Those are just things that you're not allowed to forget. In the math curriculum, you're not allowed to forget what perimeter is. So, but in case you did forget, perimeter is the sum of all the side lengths of an object. You want to know how long the outside of an object is. You add up all those side lengths. So let's go ahead and do that. Perimeter, P. Perimeter is equal to the sum of all the sides. So I'm just going to label the sides. There's obviously 4 sides when dealing with a rectangle. And so we know the perimeter is 98. So we're going to put, instead of P, so we're going to write the same equation, except we're going to plug in all the stuff that we know. We know that the perimeter, P, is 98. And we know that one side is 3x minus 2. And this other side is the same length. That's 3x minus 2 also. So we'll add another 3x minus 2. Then we have x squared minus 2x plus 9. That's another side. And then we add this side, which is also x squared minus 2x plus 9. I'm going to go ahead and move all this over. So we're adding up our 4 sides. And I can already see I made a mistake there. That should not be plus 2x. It should be minus 2x. You got to double check everything. It's so easy to make a mistake. That should be plus 9, not minus 9. It really pays off to just give a second glance on all your work. All right, so again, the perimeter is equal to the sum of all the sides. So the big question now is, what do we do? Well, we're looking for the length of each side. We can't find the length of each side because we don't know what x is. We have to find x in order to discover the lengths of the sides of the rectangle. So we're going to solve this equation to find x. So that's all we have to do is just solve the equation. So the big question obviously is, well, how do we do that? Well, first thing we do is we combine like terms. We can add the x terms, the normal x terms, and we can add the x squared terms. Those are like terms. This is all stuff that we learned previously in this course. We can add the regular numbers, and that's pretty much it. So we'll add the yellow. Actually, we want to write the polynomial in standard form, or descending order of power. So we'll add the x squareds first. So we'll add the blue ones first. 1x squared plus 1x squared is 2x squared, so that's 2x squared. So we're done with those ones. And now we can add the yellow ones. 3x plus 3x plus minus 2x minus 2x. That would give us 2x. Now we'll add the green, and we get 14, I believe. Yep, 14. And so as you can see, the equation is much, much simpler at this point. Now this equation just happens to be a quadratic equation. That's the equation that we is the most important equation, the most important topic that we learned in this class is how to solve quadratic equations. And but how do we know it's a quadratic equation? We know techniques to solve a quadratic equation, but if we don't know that it is a quadratic equation, obviously we can't use the techniques. So how do we know it's a quadratic? Well, we know it's a quadratic because you have an x squared term, an x term, and a normal term. So I can see that this is going to be a quadratic equation. I have to use the methods that we learned to solve quadratics. The problem is it's still not in standard form. We're making progress to put it in standard form, but we still have to do some more work here to put it in standard form. Remember, when you have a quadratic equation, this side has to be 0. So we're going to have to subtract 98 from both sides. And when you subtract 98 from both sides, you get over here negative 84. So I just did 14 minus 98. And that looks right. All right, so this equation is in standard form. So now, hopefully, this is starting to look familiar. Now, a lot of students will look at this and they'll say, I don't have any idea what that is. Well, that's just because you're not used to recognizing quadratic equations. But you need to recognize these equations, so you got to get used to this quick. Now, there's one more thing that we can do to make this finding the solution easier. You see how this equation has 2's and an 84. Those numbers are all even. So to make this equation easier, we can actually divide both sides of the equation by 2. So I'm just going to rewrite that because I want you to see exactly what I'm doing there. We learned how to divide both sides of we learned how to divide a polynomial. This is a polynomial, a trinomial specifically. We learned how to divide a polynomial by a monomial. You just divide each term. First of all, 0 divided by 2 is just going to be 0, so that's not going to change. But then we do 2x squared divided by 2, which is just x squared, and 2x divided by 2, which is x, and 84 divided by 2, which is 42. You can do that on the calculator if you want, but that's a pretty easy calculation. All right, so now we have the simplified quadratic equation in standard form. And the big question is, do you remember how to do this? How do we solve this? Well, you can pause the video and think about it for a couple seconds if you want. But if you just want me to show you, remember, we have to use a special method to solve this quadratic, and that method is factoring. You put 2 sets of parentheses, and we have x squared, so it's going to be x and x. And you have to ask yourself, what 2 numbers multiply to negative 42 and add up to 1? Now you might be thinking, well, where did I come up with 1? Well, remember the coefficient here, we don't see a coefficient in front of x, so it's just assumed to be 1. So again, what 2 numbers multiply to negative 42 and add up to a positive 1? So you can pause the video for a second if you want to think about that. If you don't want to think about it, then the numbers are positive 7 and negative 6. So we factored. All we did was just change this expression. We changed the form of this expression to this. And obviously the big question is, why did we do that? Who cares? Who cares that this equals this? Well, we care because now we can see the solutions. The solutions are x is equal to negative 7 and x is equal to positive 6. And if you want to know the logic behind that, I'm not going to explain that now. Remember, it's just the opposite signs. But if you have a coefficient in front of the x, then it's going to be a little bit more difficult. But this is all just review. I'm just going to write the answers. I'm not going to explain why that is. Hopefully you understand by now why that is. Now we have to, a lot of students would just stop there and they'd go on to the next problem. They'd say, we found the solution, we're done, let's go on to the next problem, give ourselves a pat on the back and move on. Well, we're not done with the problem. If you move on, you get the problem wrong. You get the wrong answer. Because it says, find the length of each side of this rectangle. We haven't found the length. All we found was x. And we actually haven't even found x yet because we have two solutions. So how do we deal with two solutions? Well, one of these solutions is an extraneous solution. It doesn't make any sense in the actual problem. So can you figure out which one of these solutions doesn't make sense in the actual problem? Look back at that rectangle. If you plug in negative 7 to x, then this side is going to be negative 23. But you can't have a negative side. That's impossible. You can't have a negative length. So negative 7 is an extraneous solution, and we can just say not equal to. And we're not going to rectangle 6 because that's not our answer. We're just going to use 6. So 6 is the actual answer for x. So now we're going to plug in 6 and find those actual sides. So x equals 6. And I'm going to say, I'm just going to plug it in. So 3 times 6 minus 2, I think that's what it is. 3x minus 2. I'm going to write the expression first, though. 3x minus 2. So that's the expression. So we're going to plug it in. And it's going to become 3 times 6 minus 2, which is 18 minus 2. I guess I can move it over. And we end up with 16. And we have to write the unit. So it says here inches are our units. So we can write IN for inches. Sorry I'm making the screen jump around like that. I hope I'm not making you sick there. So those two sides are 16 inches, this side and this side. But whenever you give the dimensions of a rectangle, you usually only give the width and the length. You don't have to say the width twice or the length twice. So now we're going to go to the other expression, x squared minus 2x plus 9. X squared minus 2x plus 9. That's the expression for the width. So now we have to plug in. We're going to plug in 6 for our x value because we found out that that's what x equals. So 6 to the second power minus 2 times 6 plus 9. I just plugged in 6 for all the x values. Now we have to follow PEMDAS, order of operations. We have to do parentheses first. Everything in the parentheses is already simplified, so we're going to do exponents next. And I'm going to do multiple operations at once because we don't have enough room here. So sometimes you can do multiple operations. In other words, I'm just doing more than one step at the same time. So 36 minus 12 is 24. 24 plus 9 is 33. So we have 33 inches. So 2 of the sides are 16 inches and 2 of the other sides are 33 inches. So we found the length of each side of that rectangle. All right, let's do one more of these together before you try one on your own. The perimeter of the triangle below is 40 feet. Find the length of each side. So it's the exact same problem. We're just doing the same thing. And if you want to, you can go ahead and try this problem on your own, or we can just do it together. So if you want to try it on your own, pause the video. If you don't want to try it on your own, that's okay. We'll do it together. So again, the perimeter is equal to the sum of the sides. And I'm not really defining what S1 and S2 and S3 mean, but I just don't want to. I don't have the energy for that. You can just, I mean, it's obvious that we're just dealing with the sides. So side 1, side 2, side 3. Doesn't really matter which one is which. And we know that the perimeter is 40. The problem tells us that the perimeter is 40. Now side 1 will make that 2x minus 1. Side 2 will make that 3x plus 3. And side 3 will be x squared plus 2. So the only reason that I wrote this is just to show you, what perimeter is, what we're doing here. So let's double check that. Everything looks right. So now we have to solve this equation, and it's just the same steps we did. We have to simplify the equation by combining like terms, and then I can see that it's going to be a quadratic equation. I know it's going to be a quadratic because we have a squared term and we have x's and we have normal numbers, so it's going to be a quadratic. Unless we have things that cancel out, then it would not be. So x squared, there's nothing to combine with that. I'm going to color code all this stuff again. And we have the normal x terms. We can combine those. There's 2 of those. And then we have the normal numbers. So 2x plus 3x is 5x. And negative 1 plus 3 is 2. And 2 plus 2 is 4. So that was quite a big step there to simplify everything. I'm just double checking everything looks right. So now all we have to do is just put everything on the right side of the equation. So we have to make this side 0. So we're going to subtract 40 from both sides. That makes the left side 0. And 4 minus 40 is negative 36. So now we have a quadratic equation that's simplified and it's in standard form. You must do both of those things. You must simplify and you must put it in standard form, or else we're not going to be able to use our factoring method to solve the equation. So now we have to factor. Now, again, you can pause the video if you want to try this on your own. If you don't, that's okay. You're going to try one after we finish this problem. You're going to try a couple after we finish this problem. So what 2 numbers multiply to negative 36 and add up to 5? Well, obviously that would be plus 9 and minus 4. So why did we do that? Well, we did it because now we can see the 2 solutions, negative 9 and 4. But just like in the other problem, if we plug in negative 9, that's going to give us a negative length. There is no such thing as negative length. So this is just an extraneous solution. We can just cross that out. So now that we know x is 4, again, we want to find the side length. We cannot find the side lengths because we don't know x. Or we didn't know x, now we do. So now we're going to plug in x. I want to make sure I have enough room here. So x is equal to 4. So we'll start with 2x minus 1. 2 times 4 minus 1. That's 8 minus 1, which is 7. And what are the units? Looks like it's feet. So we can write ft for feet. That's the length of one side. Now we're going to plug in 4 for 3x plus 3. 3 times 4 plus 3. That's 12 plus 3 is 15 feet. Now I have x squared plus 2. That's the last side. So 4 squared plus 2 is 16 plus 2, which is 18 feet. So those are the 3 sides. Again, the rectangle had 4 sides, but we know that the length and the width are the only numbers we really need to know. We don't have to write all sides. Technically, I guess you should write all 4 sides, so it'd be 16, 16, 33, and 33, but I'm not going to do that. I just don't have enough energy right now. I think you get the point. All right, so that's how we do these problems. Now it's time for you to try attempt number 3, and when you come back, we'll do it together. So if you got those answers, good job. So why don't you try number 4, and when you come back, we'll do it together. So if you got those answers, good job. So again, that was a geometry example. We don't have time to give every single type of word problem out there, every type of geometry problem, but that was a very important example. And we applied our knowledge of quadratic equations and adding like terms, and we also divided a polynomial by a monomial, and so we solved the quadratic equation. We simplified the equation, put it in standard form, so we're using all types of concepts that we learned in previous classes in this course. And we reviewed perimeter. But now we're going to go to another really important thing that you're not allowed to forget, and that is the area of a rectangle. A rectangular garden contains an inner rectangle with soil and plants and an outer walkway. So the inner part is the brown with the green shrubs and trees, and the outer walkway is the orange part down there, if you can see that. The width of the inner rectangle is 3 more yards than the length, and the area of the entire garden is 134 more square yards than the area of the inner part. What are the dimensions of the garden? So I know what you're thinking. You're thinking this is really difficult, or it sounds really difficult, but this problem really is not that difficult, as you'll see when we do this problem. So we're going to start with this information. The area of the entire garden is 134 more square yards than the area of the inner part. So let's write that down. The area of the entire garden, so I'm going to say G for garden, is equal to 134 more square yards than the area of the inner part, so I'll just put I for inner part. So that's going to serve as our most important equation here. So now all we have to do is just find expressions for the area of the garden and the area of the inner part. Looks like I'm going to probably have to move this down here. Now we have to label the garden. I'm going to write, I don't want to mess up this picture, so I'm just going to rewrite this over here. We know that this width here is 1 yard, and this width is 2 yards, and this width is 2 yards. So we have those dimensions on the picture. Those aren't given in the text, but they're given in the picture. And we know that the width of the inner rectangle is 3 more yards than the length. So if the length is x, I want to make this length x. So if that's x, then this length would be, this green would be x plus 3. So now we're ready to go back to our master equation down here. So we're first going to find the area of the inner part. That's going to be really easy. So the area of the inner part, again, if I take this inner rectangle out, then we have x plus 3 and x. Or maybe I should write those outside of the rectangle. It doesn't really matter, but x and x plus 3. So to find the area of a rectangle, you do what? Do you remember how to do that? Do you remember how to find the area of a rectangle? Again, this is something that you're not allowed to forget. If you forgot, the area of a rectangle is length times width. So we're going to take the length and multiply by the width. And that gives us the area of the inner circle. So x times x plus 3. So again, that's AI, the area of the inner circle. And we're just going to rewrite the 134. Might as well color code everything. And area of the garden, we have to find expressions for the area of the garden. So we have to find the width of the entire garden and the length of the entire garden. So this distance here is x plus 3. If you look up at this rectangle, this is x plus 3. So these distances are 2. So we want to find the total width not just this width, not just the green part, but we want to find the total width, which I could label as the purple. We want to find all the way from here to here. But you see, we have to add 2 to this expression. Actually, we have to add 2 times to find the total width. So we're going to take x plus 3 and add 2 here and add 2 here. And that's going to give us the total width of the entire garden, because we want to know the area of the entire garden. In fact, I guess I can just leave those. So x plus 3 plus 2 plus 2. And I guess I can write that out. X plus 3 plus 2 plus 2. That's the width. And then I'm going to multiply that by the length. So now we have to find the length. Now we know that this part here is x, this red part, but we have to add 1 here and 1 here to get the total length. So I'm going to use blue for that. We want the total length, which is this distance here, the total length of the rectangle. Again, we're looking for the area of the entire garden now. So we have to add these 1s to that red x. So x plus 1 to get the total length. X plus 1 plus 1. And now we're just going to simplify. Let me color code that first. So we'll simplify this inner part here. That will be x plus 7. And this part would just be x plus 2. Again, I just added those numbers. And we'll just rewrite the other part. I'm sorry it's taking so long to color code these things, but I really think that it's going to help you to visualize what's going on here. All right, so now we just have to solve this equation and find x, and then x is going to help us find the dimensions of the garden. Now, if in case you don't know, dimension just means we're going to try to find all these lengths. We're going to try to find this length and the inner lengths and all that stuff, all the numbers that the numbers of the picture, the measurements. So obviously the big question is, what do we do now? How do we solve this equation? Well, to solve this equation, we have to expand everything first. So we have to multiply these expressions. Now, how do I know that I have to multiply the expressions? Well, because I just can't solve this equation. I have no way of solving this equation. There's no other way to do it other than to expand. So this is just something you're going to have to memorize. When you get to this stage, just expand everything or multiply. So we're going to have to use FOIL here. Remember FOIL? We're multiplying two binomials. So x times x is x squared. That's f of FOIL. And then O of FOIL is x times 2 is 2x. And then I of FOIL is 7 times x is 7x. And L of FOIL is 7 times 2 is 14. So we expanded that purple part. And now x times x is x squared. X times 3 is 3x. So we expanded all those expressions. So now we just have to combine like terms. Now something special is going to happen here. First of all, that's 2x plus 7x, that's going to be 9x. And there's really nothing to combine over here. I'm going to stop color coding because it's taking too long to color code all this stuff. I think you got the point. So now what we're going to do is we're going to try to put the x squared terms together on one side of the equation. So if I want to put this x squared term on the right side of the equation, I have to subtract x squared from both sides. But look what happens. If you subtract x squared from both sides, that cancels out both those x squareds. So the x squareds, they both cancel out. And you're just left with 9x plus 14 equals 134 plus 3x. And then we want to move all the x's to one side of the equation, so I'm going to subtract 3x from both sides of the equation, and I get 6x is equal to, I'm going to move all the normal numbers to the right side of the equation, so I'm going to subtract 14 from both sides, and I get 120. So at this point we're out of room, so I'm going to have to put an arrow. Whenever you run out of room, you can just put an arrow up here. And I'm going to divide both sides of this equation by 6, and I get x is equal to 20. So what are we looking for? We're looking for the dimensions of the garden. So when they ask for the dimensions of the garden, that means we can just find the total dimension. We don't have to find the dimension of the inner part, just the dimension of the total, the whole garden, the entire garden. So we want the length, which is here, and we want the width, which is down here, the width of the entire garden. So that would be this information down here in purple. That represents the entire width and the entire length. We can just plug in x. L is equal to x plus 2. And if we plug in 20, we get 20 plus 2, which is equal to 22, and that would be yards. And then over here, because we don't have much room, so over here we can plug in x equals 20 to find the width, and the width is equal to x plus 7. Plug in 20 for x, and we get 27 yards. So we found the width of the entire garden and the length of the entire garden. All right, on to the next problem. Let's try one more of these before you try one on your own. Now I'm going to go a little bit faster here because you probably were thinking to yourself that took too long. So these problems really don't take that long, as I'm going to demonstrate now. So first let's read this. A rectangular wedding invitation has an outer border that is decorated and an inner rectangular portion with text. The width of the inner portion is 4 inches less than the length, and the area of the entire invitation is 3 times the area of the inner portion with text. Find the dimensions of the invitation. So again, I know how intimidating this can look to students who haven't done many of these problems, but don't worry. We'll start off with the same type of equation. The area of the entire invitation is 3 times the area of the inner portion with text. So we'll start with that. So the area of the entire invitation, which I'll notate as I, area of the entire invitation is equal to 3 times the area of the part with text. So now we just have to figure out an expression for the area of the whole invitation and an expression for the area of the part with text. So I'm going to move this over a little bit. So I don't want to mess up my drawing, so I'm going to just redraw it over here so you can see what's going on. So we know this is 1, we know this is 2, we know this is 2, we know this is 1. And notice that these drawings are not drawn to scale, so don't get your ruler out and think you're going to solve it with a ruler. Let's see. We also know that the width of the inner portion is 4 inches less than the length. So the width of the inner portion is 4 inches less than the length. So the length, if the length is x, then the width would be x minus 4. That looks correct. So I'm going to color code this. Probably should have done that last time. So I'm going to move this down. So we can start with the area of the inner text part, AT. That's going to be really easy because that's just, again, the area of a rectangle. The inner part is a rectangle. So the area of a rectangle is just length times width. So we just do x times x minus 4. I guess we can put brackets just so you can be sure what's going on. And area of the entire invitation, that's going to be, again, length times width because they're both rectangles. We want to find the area of the entire rectangle. That's the whole thing. So we just take the width and multiply it by the length. Now we know that this inner part is x. This part here, let me find a different color there. This part here is x. So to find the total length of the whole thing, we just have to add 1 here and 1 here, so it becomes x plus 2. So that's the length of the entire invitation, x plus 2. I have to multiply that by the width. And the width, and let me just write x plus 1 so you can see what's going on there. So the width, this part here is x minus 4. So then we have to add 2 here and 2 here. So we take x minus 4 and add 2. You get x minus 2. Well, I'm just going to go ahead and write it so you can see what's going on. So x minus 4, and then you have to add 2, and add 2 again to get the total width. Whoops. So x minus 4 plus 2 plus 2. So now we just simplify and we solve the equation. So to add those 1's together, we get x plus 2. And then add all the negative 4 and the 2's together, and we get just x. I'll move that over a little bit. And we can go ahead and multiply the 3 and the x, and it just becomes 3x. Now you might be tempted to distribute. You might say, well, I'm going to distribute the 3 into the x and the 3 into the x minus 4. Don't do that. That's not the distribution rule. The distribution rule doesn't say 3 times ab is equal to 3a times 3b. It does not say that. That's one of the most common mistakes that students make. What the distribution rule says is that 3 times a plus b is equal to 3a plus 3b. That's the distribution rule. So this is not correct. This is correct. So we don't have to use the distributive rule because we don't have a sum. We just have x times x minus 4. All right, so now we're going to expand x times x plus 2. Then you're going to use the distributive rule. So x times x is x squared. X times 2 is 2x. And you're going to use the distributive rule here. So 3x times x is 3x squared, and 3x times negative 4 is negative 12x. So I just want to clarify, you're not using the distributive rule here, but you are using it after you're done combining the 3 and the x. All right, so we're going to put all the x squareds on the same side. So this is a quadratic. There's going to be some sort of quadratic. Actually, we're not going to use the same methods as before because this is going to be slightly different. But we're going to put all the x squared terms on the same side. So subtract x squared from both sides. This disappears, and we end up with 2x squared because we subtracted 1 from the x squared. And we're going to subtract 2x from both sides, and that'll make the negative 12 turn into negative 14x. And we just get 0 because there's nothing on the left side of the equation. Now, at this point, we can see there's something different happening here. In the previous problems, we had, in the previous problem, we didn't have a quadratic at all. In the perimeter problems, we ended up with quadratics in every problem. But here we have something a little different because even though we have an x squared term and an x term, we don't have a normal constant term. So this is going to be a little bit different. We learned in a previous class that when you have this situation, you can solve by simply factoring out a greatest common monomial. So what is the biggest number that goes into both 2 and 14? Well, obviously that would just be 2. And we want to find the smallest x power, which is just x, so we pull out the x. So the greatest common factor is 2x, and then 2x times what equals 2x squared? Well, obviously that would just be x. And 2x times what equals negative 14x? Well, that would just be 7. So I know what you're thinking. You're thinking, we didn't do this. Well, actually, we did do it. We learned this in the class on, I think I entitled it more factoring problems or something like that. It's just one of the classes where we learned the different types of factoring. So now we see the solutions. One of the solutions is x equals 7. That's what this factor tells us. In fact, I'm going to write that on the other side. X equals 7, and this factor tells us that x can be 0. So x can be 7 or x can be 0. But obviously x is not going to be 0 because that doesn't make any sense in our actual problem. So x is going to be extraneous. We're just going to say not equal to, because if you make x 0, then that would mean this length is 0. And obviously we can see that that's not true. So x is going to be 7. So now we just have to find the dimensions of the invitation. So I'm just going to find the width and the length. Now we know that the length is x plus 2, and the width is just x, because we figured that out previously. So the length is x plus 2, and so x is equal to 7. So 7 plus 2 is equal to 9, and the units are inches. So we can say IN. And I'm going to make a border there. So now we know if we plug in 7 to the width, we know the width is equal to x. Therefore, the width is equal to 7 inches. All right, so on to the next problem. Now it's time for you to try. I know these problems are really intimidating, but if you want, I can leave these in the window for you, and you can take a screenshot. Actually, just go ahead and take a screenshot of these two problems, and you can refer back to those. So now it's time for you to try number 7, and when you come back, we'll do it together. All right, we're back. So the most important equation is generated from the total area of the rectangular backyard is 50 square meters more than the area of the rectangular pool at the center of the yard. That's our master equation. So area of the entire backyard is equal to 50 square meters more than the area of the rectangular pool. I'll put P for pool at the center of the yard. Now the area of the pool, that's going to be, let's bring this down. I want to draw another picture off to the side so we can see what's going on here. So 1.5, 1.5, 1, and 1. Even though that doesn't really look right, but it doesn't really matter. And we're told the length of the pool is 2 meters more than the width. So the length is 2 meters more than the width. So if the width is x, then the length must be x plus 2. So again, that's this part. So now the area of the pool is, again, really easy. Area of a rectangle, because the pool is a rectangle. Area of a rectangle is just the length times the width times the length, however you want to say it. Doesn't matter what order. And the area of the entire backyard, that's going to be, the width is, this part here is x, and then we add 1 here and 1 here. So it's going to be x plus 1 plus 1. And then the length, we know this part here is x plus 2. So then we just add 1.5 to that 2 times to get the total length. So we have x plus 2, and then plus 1.5 and 1.5 again. So obviously I'm going to have to move this down. All right, so now we're going to simplify as usual. X plus 2 times x plus 5. So now we're ready to expand. We got to use FOIL here to expand. So we have x squared plus 7x plus 10. And I just added the inner terms together in my head. So because we're running short on time. X times x. So again, we use FOIL here, but in this problem we use distribution. So x times x is x squared x times 2 is 2x. So again, we're using a lot of principles here. So now, if we subtract x squared from both sides, the x squareds just disappear. So that's good. We don't have to deal with the quadratic. Subtract 2x from both sides, and we get 5x over here. And subtract 10 from both sides, and we get 40 over here. Divide both sides by 5, and we get x is equal to 8. So now we just have to find the dimensions. So we know that the what would that be? That is the width is x plus 2. And we know that x is equal to 8, so we're going to plug it in there. 8 plus 2. So the width of the entire backyard is 10, what are we dealing with here? Meters, 10 meters. So we can put m for meters. And if you don't know the abbreviation for meters, that's okay. You can just spell it out. So then we plug in 8 for the length. And we know the length is x plus 5. So 8 plus 5 is 13, and then meters. So the entire backyard is 10 by 13. So if you got those answers, good job. All right, on to the next problem. So I'm going to keep that problem in the window for you. Try number 8, and when you come back, we'll do it together. All right, we're back. So the most important equation is the area of the base of the house and the walkway combined is 64 square yards less than twice the area of the base of the house. So I'm going to write that down here. Well, I can move it down later. So area of the area of everything combined, so I'm going to put C for combined, is equal to 64 square yards less, so that's going to be minus 64, then twice the area of the base of the house. So I'm going to say AB for the area of the base of the house. It has to be twice the area of the base of the house. So that equation is more difficult than the other equations we've done so far. So let me just double check that. That looks correct. So I'm going to move this down. Now that we have that equation, we can move down. And I'm going to draw, again, I don't want to mess up the original drawing, so I'm going to just draw a crude equation down here, a crude picture. So again, we know this is 1 yard. In fact, it's just 1 yard all the way around the walkway. And let's see, the length of the house is 1 yard less than the width. So the length is 1 yard less than the width. All right, so we're ready to go at this point. So let's do the easy part first. The area of the base of the house, that's just going to be x times x minus 1. Again, that's how you find the area of a rectangle, and it's a rectangle. And the area of the combined house and the walkway is going to be, let's find the width. So the width is x, but then you have to add 1 twice to get the whole width. So we know this distance here is x, but then we have to add these distances to get the whole width, so then it becomes x plus 1 plus 1. Then we're going to multiply that by x minus 1 is the length of the inner part. That's this part here, or this part if you want to look at this other diagram. But then you have to add 1 to both for both sides there to get the total length. So plus 1 and plus 1. So now we just have to simplify. We get x plus 2 times x plus 1. And we can just put that 2 next to the x, get rid of those brackets. And I know this is going to really make students nervous how I did that, but again, that's just basic algebra. If you want, you can multiply x times x and then x times 1 first. That's just another way to do it. That'll probably be easier for you actually now that I think about it. So let's go ahead and do it that way. So x times x is x squared. X times negative 1 is negative x. So this is probably a little easier for you. Now we're going to go ahead and expand this. We get x squared plus 3x plus 2. Then we'll distribute there. We get 2x squared minus 2x. And subtract x squared from both sides, and you get x squared. Subtract 3x from both sides, and you get negative 5x. Subtract 2 from both sides, and you get negative 66. Now again, I could have put everything on the left side of the equation, but then you'd have a negative x squared if you put it over here. We don't want a negative on the squared term. So let me just double check that. Everything looks right. And we have a 0. Don't forget your 0 on the left side of the equation. So now we have to solve that quadratic. It's in standard form. It's been simplified. And I'm going to go ahead and move this up a little bit. So we factor what two numbers multiply to 66, negative 66, and add up to negative 5. Well, that would just be negative 11 and positive 6. So our answers would be x is equal to 11 or x is equal to negative 6. So negative 6 obviously doesn't work because we can't have a negative length. So then we plug in 11. Actually, it wants the dimensions of the house. And I just realized in the previous problem, it wants the dimensions of the pool. So in these two problems, it was probably okay to just write the overall dimensions. But in these problems, we need to find the dimensions of the pool. So this would be combined. But now we want to find the dimensions of the pool, so that would be pretty easy. The pool would just be x is 8, so the length would be 10, and the width would be 8. And we have meters. As you can see, we don't really have a lot of room here. And over here, it says, what are the dimensions of the house? So we actually, now that I think about it, these are not really the answers. We want the dimensions of the actual house. So sorry I didn't warn you about that. But if you got this far, that's good. You did it correctly. We just need to find the final solution, which are the dimensions of the house. So we can get rid of all this. We don't really need that. I found the combined dimensions. We don't really want that. So the dimensions of the house, that would just be, if you let x equal 11, then the width is equal to x. Therefore, the width is equal to 11 yards. And again, letting x equal 11, the length of the house would be equal to x minus 1. So we just plug in 11 and we get 10 yards. So the width of the house is 11 yards and the length is 10 yards. That makes sense because the width should be one less, or the length should be one less than the width. So if you got those answers, good job. All right, on to the next problem. We did some geometry problems, perimeter and area. And now we're going to do problems that deal with objects in free fall. For example, if you drop an object from a building and you want to know the height of the object after a certain amount of time, that's these problems. So let's start our first one of these problems. After flying for a few moments, a toy rocket starts to descend. If we neglect air resistance, the height in feet of the rocket after t seconds of free fall can be modeled by the following formula. Find the height of the rocket 3 seconds after free fall. That's part A, and then we have to figure out how many seconds after free fall will the rocket or will pass before the rocket is 80 feet above the ground, 100 feet, so on and so forth. So there's multiple parts to this question. So we're starting with part A. Let me just get rid of this highlighter. So for part A, let me just go over what this equation means. So what this means is we have the height. This is the height after a certain number of seconds after free fall. So when an object starts to fall, so it's part A, h is equal to -16, and then we plug in 3 squared plus 200, because it wants to know 3 seconds after free fall, so we plug in 3. So all I did with this equation is I plugged in 3 to t, and then I'm just going to figure out what h equals. So now we have to follow PEMDAS, the order of operations. So PEMDAS tells us parentheses first. There's nothing to simplify in the parentheses, so we just skip to exponents. So we do the exponents. 3 to the second power is 9. And PEMDAS tells us to do multiplication next. So -16 times 9 would be -144. And -144 plus 200 will be 56. So the object will be 56 feet above the ground after 3 seconds of free fall. So that's part A. So as you can see, that part was really not very difficult. All we had to do is just plug in the t value. So now we move on to part B. Let me go ahead and color code this. How many seconds after free fall will pass before the rocket is 80 feet above the ground? So in this case, instead of plugging in the t value, we're going to plug in the h value. So we're told that h is 80. So we don't know what t is. We're looking for t, the time that's passed after free fall, when the object is 80 feet above the ground. So we plugged in 80 for the height, and we're looking for t. So this is an equation where we have to, it's an equation with squares. We learn how to solve equations with squares. So what you do is you isolate the square, and the square is t squared. So we have to isolate t squared. T squared right now is not isolated because the -16 is next to it and the 200 is next to it. So first we're going to subtract 200 from both sides, and we get -120 on the left side, and the 200 disappears on the right side. And now we're going to divide both sides by -16, and 120 divided by 16 is 7.5. And actually, I'm just going to reduce it. So I'm going to keep 120 over -16. And if you reduce, divide both sides of the equation by, let's see, we'll try dividing by 8. If we divide both sides by 8, we get 15 over 2. And of course, a negative divided by negative just becomes a positive, so we can get rid of the negatives. And now we've isolated the square. But we're not done yet because we have to get rid of that power. We don't want t squared, we just want t. So we have to square root both sides. So we're going to rewrite. And we square root both sides. And this should be plus or minus. And when we square root, we get rid of that power, and we're just left with t. And we have plus or minus root 15 over 2. But of course, we learned in previous classes that we can't leave it in this form because we need to rationalize the denominator. So we get plus or minus root 15 over root 2. If you recall that rule we learned. Again, root A over B is equal to root A over root B. We learned that in a previous class, the class on roots. And now we're going to multiply both sides by root 2. I don't really have a lot of room to show all this, but I really don't want you to get stuck because you don't remember what we did in the last classes. So multiply both sides by root 2 just using the fundamental principle of fractions. And we end up with root 15 times root 2 is root 30. And root 2 times root 2 is 2. And that's the final answer. But we can't have negative time. So we can just get rid of that negative and just say positive root 30 over 2. And we have to write S for seconds. I'm going to move that down because we can't really see what's going on here. You must write S. You must write your units. All right, so that was part B. And now we're going to go on to part C. Part C wants to know, we're doing the same problem, except now it's 100 feet. So we put 100 equals negative 16t squared plus 200. So subtract 200 from both sides. Negative 100 equals negative 16t squared. Divide both sides by negative 16. And I'm going to reduce that. And that reduces all the way to 25 over 4 if you divide both sides by 4. And now we're going to square root both sides. Square root by both sides of the equation. And as usual, we have to put plus or minus. And using the same principle, we have square root 25 over square root 4. And that's going to be really easy, because square root 25 is 5, and square root 4 is 2. And of course, we can get rid of the negative because time cannot be negative. So we're left with 5/2 seconds. Now, if you want to change that to a decimal, you can. And you can change this to a decimal. You probably have to change this to a decimal so it actually means something in the real world. But we're just going to leave it in that form because I want you to get practice with roots. So t equals 5/2 seconds. I'm just going to put SEC for seconds because I don't want you to be confused by the S there. All right, so again, after 5/2 seconds, it's going to be 100 feet off the ground. And now we do part D. When will the rocket hit the ground? So I'm going to see if I can fit part D here. So when the rocket hits the ground, H is going to be 0. So here we had H equals 80. Here we had H equals 100. But we want to know when it's going to hit the ground, and it'll hit the ground when H is equal to 0. So we'll let H equals 0. 0 equals negative 16t squared plus 100. So now we just solve for t squared again. Same situation. We subtract 100 from both sides, and we get negative 100 equals negative 16t squared. Divide both sides by negative 16. Whoops, that shouldn't be 100. I'm sorry, that should be 200. Subtract 200 from both sides, we get negative 200 over here. And divide both sides by negative 16. And reduce that, and we get, I think that would be 25 over 2 equals t squared. Now we're going to square root both sides because we have to get rid of that square. We get plus or minus. And now we have square root 25 over square root 2. And square root 25, that's just going to be 5. So now the problem that we have is we have to rationalize the denominator because we can't have a root in the denominator, right? So I'm going to have to make some more room here. Alright, so we're out of room, so we're going to have to draw a line up here. And we're going to rewrite. And by the way, you don't have to show all these steps where we're rewriting the root. I'm just doing it so you remember how to rationalize denominators and the various rules that we're using. And we're going to multiply both sides by root 2 because we want to get rid of that root. 5 times root 2, we can just write 5 root 2. Root 2 times root 2 is root 4, but that would just be 2. And we can get rid of the minus, so our final answer is going to be 5 root 2 over 2 seconds. And again, in the real world, you would actually plug that into a calculator and change it into decimal form, but I just want you to leave it in root form to practice your roots. Alright, so a lot of parts in that problem. Let me color code here. Alright, on to the next problem. Why don't you try number 10? And you might want to review your rules about roots. You might need your rules on roots. We already looked at one rule here. But go ahead and try number 10. It's going to be very similar to number 9. And I'll leave number 9 in the window. When you come back, we'll do it together. Alright, we're back. So part A, I'm going to try to write smaller this time. What is the height of the acorn after 2 seconds in the air? So all we have to do is just plug in 2 to t. So negative 16 times 4, use PEMDAS, and negative 16 times 4 is negative 64. Negative 64 plus 73 is 9, so it looks like it's going to be 9 feet. So part A would be 9 feet. Alright, part B. How long will it take for the acorn's height to reach 60 feet? So that's what we're doing here. So we're going to let h equal 60. We're going to subtract 73 from both sides, and we get negative 13. Divide both sides by negative 16, and we get 13 over 16. Negatives go away because obviously a negative divided by negative is a positive. So now we're going to square root both sides. And you don't have to rewrite at this point, but I'm just rewriting so you know exactly what's happening here. T is equal to, and we're going to change to square root 13 over square root 16. And of course, square root 16 is a perfect square, so square root 16 would just be 4. And of course, we get rid of that negative. There's no such thing as a negative time. So we have square root 13 over 4 seconds equals t. And again, you would normally change this to a decimal, but I just want you to leave it as a root so you can practice your roots. So if you got that answer, good job. On to part C. So for part C, wants to know how long it'll take for the chipmunk to be 35 feet in the air. So we let h equal 35. And subtract 73 from both sides, and we get negative 38. Divide both sides by negative 16. And that would be 19 over 8, I believe. And square root both sides. And t is equal to square root 19 over square root 8. So now we have two problems. One problem is we don't have a rationalized denominator. We have a root in the denominator. And the second problem is we have a perfect square inside that root. So I'm going to pull out a perfect square. So 8 is 4 times 2. I guess I'm going to show every step here. So I don't want to confuse you. And now we're using a different rule. We haven't used this rule yet today. Root A times B. I'm going to write this over here. Root A times B is equal to root A times root B. So root 4 times root 10 is equal to t. We got root 19. Root 4 is 2. So now we took care of that problem. We don't have a root in the, we don't have a perfect square in the root. So now we have to take care of the problem of the root in the denominator. We can't have a root in the denominator, so we're going to multiply both sides by root 2. And root 2 times, well, I guess I'm going to show that. Actually, I don't really have room to show that. If you don't understand what I'm doing here, you can go back and look, but we just don't have room to show every step here. Root 2 times root 19 is root 38. And root 2 times root 2 would just be 2, and then you're left with 2 times 2 is 4. And obviously you want to get rid of the negative because that's not going to be one of our answers. You can't have a negative time. So our final answer is root 38 over 4 seconds. On to part D. Now I want to know how long it'll take for the acorn to hit the ground. So now we're going to let the height equal 0 and solve for t. Subtract 73 from both sides. Again, we have to isolate the t squared. And now square root both sides. So t is equal to square root 73 over square root 16. And square root 73 we can't do anything with, but square root 16, that's just 4 because that's a perfect square. And of course we can get rid of our negative. No such thing as a negative time. So there's our final answer. Alright, so if you got that answer, or those answers, good job. Alright, on to another one of these types of freefall problems. This is going to be a slightly different variation. Sorry, the screen keeps jumping around. I don't know why it's doing that. A boy kicks a soccer ball into the air. Neglecting air resistance, the height and feet of the ball t seconds after it's kicked can be modeled by the equation below. How high is the ball 2/5 of a second after it's kicked? So these are the same problems. The only difference is this equation is a little bit different. So part A, we're just going to find the height when t is 2/5. Now notice we have to plug in 2/5 in two different places because there's two t's. This is a different equation. So now all we have to do is follow PEMDAS, but the problem is we have fractions, so it's going to be a little bit more involved. And so again, we have to use PEMDAS. So 2/5 to the second power, that's 2/5 times 2/5. So I'm just going to write that out, 2/5 times 2/5. And when you multiply fractions, you just multiply straight across. And this 10 I'm going to change to 10 over 1. So again, when you multiply, you're going to multiply the 2 straight across, multiply the 5 straight across. You're going to multiply the 10 and the 2 straight across, and the 5 and the 1 straight across. That's just how you multiply fractions. That's also something that you're not allowed to forget, by the way, if you did forget that. So 2/5 times 2/5, that would be 4 25ths. And 10 times 2 is 20, and 5 times 1 is 5. So continuing here, -16 times 4 25ths, that would be -64. And by the way, we just write the -16 over 1. And you don't have to show all of these steps. You can just do it. I'm showing the steps because I just want to make sure that you don't forget the basic arithmetic. So 20 divided by 5 is 4. And -16 times 4 is -64. 1 times 25 is 25. And so now I'm going to change this to a mixed number. 25 goes into 64 2 times. And 2 times 25 is 50. The remainder is 14. So if you don't remember how to change an improper fraction to a mixed number, just go back to my arithmetic course and look at that. And you can just do the basic math here, and it's obvious that this is going to be 1 and 11 25ths. Again, if you don't remember how to do that, just go back to my basic, my arithmetic course. And that would be, what are we dealing with here? That would be feet. So that's how high it's going to be after 2/5 of a second passes, since the ball is kicked. All right, on to part B. Let me color code that. When will the ball be 1 foot in the air? So we let h be 1. So again, we're just plugging in 1 for h. And now we just have to solve that equation. But this equation is not going to be, well, we'll see what happens. So it's a quadratic because we have t squared and t. So we have to use special methods, but we have to put it in standard form first. So we're going to subtract 1 from both sides. We're going to get everything on the right side of the equation. So this becomes 0, and we have -1 over here. So now, remember, we learned to factor, but the problem is we have a negative coefficient. I don't like these negative coefficients here. So I want to get rid of that negative. So I'm going to divide both sides by -1 because I just don't like those negatives in front of the. I mean, you can still do it with the negative in front, but I don't prefer negatives in front of the squared terms. So we're going to divide both sides by a negative, and that's going to turn everything to. It's going to make the opposite sign. So we have 0 is equal to +16t squared minus 10t plus 1. So notice all the signs changed. So now we're going to factor, and I'm going to try 4t times 4t, because 4 times 4 is 16. And what two numbers multiply to 1 and add up, and well, it's got to be two negatives, so I'm going to try -1 times -1. And now if we FOIL that back out, we don't have to check F and L because we know F and L work, but we want to choose O and I of FOIL. So O is -4t, I is -4t. -4t plus -4t is -8t. That did not work. We need -10t. So let's try something else. Let's try 2t times 8t, because 2 times 8 is 16. And then, of course, this would be -1 and -1 again. There's no other option for that. O would be -2t, and I would be -8t, which adds up to -10t. So those are correct. So now we have two solutions. If 2t minus 1 is equal to 0, that's one solution. And if 8t minus 1 is equal to 0, that's another solution. So we solve over here and we get t is equal to 1/2. And over here we get t is equal to 1/8. So it looks like there's actually two solutions to this equation. Which makes sense because it says right here, hint, there are two answers. And the reason there's two answers is because if whoever's kicking the ball, the boy kicks the ball, let's say this is the ground, and let's say that this is 1 foot off the ground, 1 foot in the air. So the boy kicks the ball and it's 1 foot here, but it's also 1 foot over here. So this is 1/8 of a second after he kicks it, and this is 1/2 of a second after he kicks it. So that's why there are two answers, in case you didn't realize. So both these answers are correct. There are no extraneous solutions. So t equals 1/8 of a second, and t equals 1/2 of a second. So two answers for part B. Now let's go on to part C. How long will it take for the ball to hit the ground? So we're doing another ground problem, and there are two solutions, but one of them is going to be not relevant. You'll see what happens. So let h equal 0. And now we have to solve this equation, and a lot of students really get confused by this special situation. We don't have a constant term here, so we're not going to really need to do the same thing we did here. We don't need, it's not really a quadratic because this term is not there. So we're going to solve this method by very different methods than we did here. What we're going to do is we're just going to pull out a greatest common factor, which would be let's see, a negative 2t I'm going to pull out, and that would be 8t minus 5. And just to check that, I'll multiply back. So negative 2t times 8t is negative 16t squared. Got it? And negative 2t times negative 5 is positive 10t. Got it? So you're probably thinking, okay, well, who cares? What did that do for us? Well, we can see the solutions now. We can see this means that t can be 0, and then because if you multiply 0 times all this, you get 0, so it works. So t equals 0 is one of the solutions. So t can be 0, but this tells us that t can be something else. 8t minus 5 can also be 0, but if you solve two-step equation, then we end up with 5/8 of a second. So 5/8 seconds. Now we don't care about this answer. We just don't care about it. Why do you think we don't care about that answer? It's a valid answer, but we just don't care. Well, the reason we don't care is because the boy kicks the ball, and obviously the ball is on the ground when he kicked it. So when t equals 0, right before he kicks it, or maybe right at the instant that he kicks it, it's on the ground. So what? We don't care about that. We just want to know how long it'll take before it gets back to the ground, and that's 5/8 of a second. So we don't even rectangle, we're not going to rectangle t equals 0. All right, so now it's time for you to try one of those problems. So I'm going to leave number 11 in the window. Go ahead and try number 12, and when you come back, we'll do it together. All right, we're back. So part A is pretty straightforward. We just want to find the height after 1/10 of a second has passed. 1/10 of a second squared is 1 over 100. I'm not going to do every step there because we don't have time for that. And 14 times 1/10 is 7/5. And negative 16 times 1 over 100 is negative 16 over 100. Actually, I'm just going to skip a step. That would be negative 8 over 50, which is negative 4 over 25. And we need to get a common denominator. Multiply both sides of this fraction by 5, and we get 35 over 25, which is 31 over 25, and it's going to be feet as usual. So probably be best if we change that to a mixed number. So I'm going to go ahead and change it. 25 goes in one time, and the remainder is 6. Again, you can go back to my arithmetic course and review how to change improper fractions to mixed numbers if you're having trouble with that. All right, so that's part A. Right, on to part B. When will the ball reach a height of 3 feet? Hint, there are 2 answers. So there's going to be 2 answers for this one. So we let h equal 3. So we're going to have to put the equation in standard form, subtract 3 from both sides. And I'm going to divide both sides by -1, but I'm not going to show that because we don't have enough time. And we're going to factor. So I'm going to try 4t times 4t again. I don't know if it's going to work. We need -3 and -3. Actually, this is not going to work. There's no way that could work. So let's try 16t times t. I have a feeling that's going to work. Actually, you know what? I'm sorry. That previous problem probably would have worked. Let's go ahead and try that. -1 and -3. So O is -12t, I is -4t. They add up to -16t, and that doesn't work. So never mind. You got to try the different options, though. You have no choice. So what about, I guess we can try 8t and 2t. -3, +1. Actually, that should be -1. And looks like that works. So t is going to be equal to 3/8 of a second. And t is going to be equal to 1/2 of a second. So again, the ball bounces off the ground, and 3 feet would be here, so there's going to be 2 times where it reaches 3 feet, here and here. So if you got those answers, good job. All right, on to part C. When will the ball hit the ground? Hint, there are 2 answers. One is relevant and the other is not. So the answer that's not relevant is going to be when t equals 0. So again, we let h equal 0. I'll move this over a little bit. Let h equal 0. And we're going to do the same thing we did before. So we're going to factor out -2t. I think that's the greatest common factor. And just multiply back. to check. That looks right. So we have two solutions. One solution is t equals 0. The other solution is t equals 7/8. So obviously the 0 solution is not really relevant to the problem, because we know that when the clock starts, the ball is going to be on the ground, because that's when it starts to bounce. That's when it bounces. So the answer is 7/8 of a second. So if you got that answer, good job. So two more of these free fall problems. We'll do the first one together. It's really just the exact same problem pretty much. We just have a slightly different equation. So what is the height of the ball after 1.2 seconds in the air? So the height is equal to -16 times 1.2 to the second power minus 8 times 1.2 plus 63. So again, we just plugged in 1.2. So it's okay to use the calculator when you have decimals. So I'm going to get my calculator out. And 1.2 times 1.2, because we're squaring it, that would be 1.44. And then 1.2 times 8, -9.6. I'm doing two steps at once. That's okay. Actually, you know what? There's no point in doing two steps at once at that stage. I don't want to confuse you. If you want to practice evaluating expressions, go back to my pre-algebra course. Let's see here. So now we're ready to calculate. So again, this becomes -9.6. And we have 16 times 1.44. All we have to do is combine those. So plus 9.6. And that would be -32.64. And then we get positive 30.36 feet. So that is part A. All right, on to part B. How long will it take for the ball to reach a height of 55 feet? So it's the same type of problem, except we'd have a slightly different equation. So we're letting the height equal 55, and we have to solve for t. So this is a quadratic equation. We have to subtract 55 from both sides to put it in standard form. And we get, looks like that would be 8. So now we can divide both sides. We want to simplify this equation. You always want to simplify a quadratic if you can. So we're going to divide both sides. I want to get rid of the negative and I want to simplify, because 8 goes into all those numbers. So I'm going to divide by -8. You have to divide both sides by -8, even though it doesn't change the left side. It's still going to be 0. 0 divided by -8 is 0. -16 t squared divided by -8 is positive 2 t squared. -8t divided by -8 is positive t. And 8 divided by -8 is -1. All right, so now we're ready to factor, because the quadratic is simplified and it's in standard form. And I'm going to try that factorization. So O would be 2t and I would be -t. So 2t minus t is positive 1t, so it looks like that worked. And so these two equations tell us that t can be 1/2 and t can be -1. But of course, time cannot be negative, so we just ignore that one. And we put seconds and rectangle. So again, these are the exact same problems, except the equation is just a little bit different. The equation depends on if the ball is going straight down or if it's moving horizontally, and so forth, so on and so forth. All right, but you don't have to worry about all that stuff. That's for physics. All right, part C. How long will it take for the ball to hit the ground? So obviously we just let h equal 0. I have to move this down a little bit or to the side. So we're letting h equal 0. And let's see here. I don't think we can simplify it at all. It's pretty much in standard form already. Well, actually, we can divide by -1. So 0 equals 16t squared. You know what? I'm just going to show that. I want you to know exactly what's going on here. I am skipping some steps in this class today, but I'm trying to show every step that I can. Because if you skip steps, then students are going to say, well, what was that? I don't understand that. Even though, and you should understand because, again, there are prerequisites for this course. So again, that just changes the signs. So now we factor. And I don't know what it's going to be, but I have a feeling it's going to be 16t because I designed these problems. So 9, and we'll try 7. And that's actually not going to work, so I'm going to switch the 9 and the 7. And I don't think that's going to work either, so I guess that was not correct. So how about 4t and 4t? Let's try that. And positive 9 and -7. And I think this should work. So the outside terms would be -28t. And the inside terms would be 36t. And we get, add those together, and we get 8t, so that works. Because we got 8t. So now this form tells us that t can equal -9 over 4, which is ridiculous because we can't have a negative time. And the other equation tells us that t can be 7/4, but I want to write that as a mixed number, 1 3/4 seconds. I don't really care if you write it as a mixed number, to be honest with you. But I just want you to know exactly what, it's kind of hard to interpret improper fractions sometimes. All right, so if you got that answer, actually no, you didn't do that problem. We did it together. So again, it's just a different variation of the same type of problem. So now it's time for you to try one. So I'm going to leave problem 13 in the window while you try number 14. So go ahead and try 14, and when you come back, we'll do it together. All right, we're back. So part A, same situation. Find the height of the rows after 0.8 seconds. So we plug in 0.8. And 0.8 times 0.8 is 0.64. And -16 times 0.64. I'll do that on my calculator. 16 times 0.64 is 10.24, so we have -10.24. And 4 times 0.8 is just 3.2. And add everything together, and we get negative 4.96. Actually, positive 4.96. That wouldn't make much sense if we got a negative height. So 4.96 feet. So if you got that answer, good job. All right, on to part B. So in part B, so he catches it at 10 feet. So we're going to let h equal 10 and solve for t. All right, so this is a quadratic equation. We have to get it in standard form. And as usual, I'm going to divide both sides by -1. I'm not going to show that though. Don't have time. And now we're going to factor. Actually, before we factor, you know what? I am going to divide by. I'm going to show the divide by -1 because I want to simplify even more. You don't have to simplify or get rid of the negative, but it just makes it a lot easier. So I'm going to divide both sides by -2. So that would just still be 0, and we get 8 minus 2t minus 1. 8t squared. And that looks correct. So now we have to factor. And I'm going to try 4 times 2. And then let's see, -1 and +1. So O would be 4t, I would be -2t. 4t minus 2t is 2t. We don't want 2t, we want -2t. So all we have to do is just change the signs. And so t equals -1/4, which is ridiculous. You can't have a negative time. And then t equals 1/2. So 1/2 second is the answer to part B. All right, on to part C. If the performer does not catch the rose and it lands on the stage, for how many seconds was it in the air? So that just means if it lands on the stage, that means we have to let h equal 0 to figure out the time that passed for it to actually get to the stage. Now, I know what you're probably thinking. You're thinking, how do we know what the ground is? Is the stage the ground? Because if you're in a performance room, an auditorium, whatever you want to call it, there's a lot of different grounds. There's the stage ground, there's the ground with the seats, there's the balconies. Well, what's the ground? Well, that's why we have this statement here. The stage is h equals 0. So the stage is considered to be 0. So I'm going to divide both sides by -4. And let's see, that would be 4t squared, -t, 3. And factor. I'm going to try 4t and t, -3 and +1. -12 and 1t, that's not even close. So I'm going to try switching these numbers. Negative 4t, positive 3t is negative 1t. So it looks like that works. Just double checking that everything looks good. So one answer is negative 3/4 seconds, but that's not correct. The other answer is 1 second. So it takes 1 second for the rows to hit the stage. So if you got that answer, good job. All right. So those were the freefall problems. Now you're probably thinking, why do we have to do so many freefall problems? Well, because they're just very common in the curriculum. We can't really avoid them. And some people might think, well, why didn't you do more variations of the problems? Well, we don't have time to do every single variation, and I don't want to overload students. As long as you get the basic idea of a few problems here and there, then that's really all you're going to need for this course. You're going to need a lot more when we go to other courses, but for this course, you're not going to need any more word problems. All right, because this is beginning algebra, remember. Any teachers who are watching this and saying, well, I would put more word problems, well, you need to understand this is beginning algebra. Don't overload students with a lot of complicated problems. Fluency in the algebra is the #1 priority of this course. All right, so now we're going to do the last thing. Today we have 4 more problems. Notice I have graphing paper, so we're going to do some graphing. In a previous class, we learned 2 ways to solve a system of equations, elimination and substitution. But there's a 3rd way to solve a system of equations, and that's graphing. That's when you take each of these equations and you graph them. We only learned how to solve systems where we had linear equations, so these are linear equations. Let's say I graph one of these equations. I graph this one, and it ends up being this line. It won't be that line, but let's just say it were. Then I graph this equation, and it ends up being this line. Then the point where they intersect is going to have an x value and a y value. And remember, when you solve a system of equations, you have to find x and y. So this x value and the y value, they're going to be the solution to this system. And that's how you use graphing to solve a system of equations. Now, you're probably thinking, well, why didn't we learn this method when we did the course on solving systems? Well, the reason is we don't really want to focus on this method because it's not really reliable and it's not practical. It's not practical because it takes a long time to use this method. And the reason it's not reliable is because if you don't have a very precise graph, sometimes you won't get the right answer. And sometimes if you cross between and in the middle of a square, the graphing paper is not going to tell you what the answer is. You'd only be able to estimate. This answer could be, the y value could be, let's see, 1, 2, 3, 4. It could be 4 and 4/5. It could be 4 and 3/5. We just don't know. The x value could be 2 and 1/2. It could be 2 and 3/5. We just don't know. So it's just not very reliable. So you're probably thinking at this point, well, wait a second, if it's not reliable and it's not practical, why are we learning it? Well, we're learning it because when you take a test, some sort of high school entrance test, some sort of competitive test, a college test, you may need to know that the point of intersection is the solution for this system of equations. It's just one of the methods that is typically taught, even though it's really kind of a waste of time because it doesn't really work. You'll also learn that when you have parallel lines, there's no solution to the system, and when you have lines that are right on top of each other, you have infinite solutions, but we're not going to go over that in this course because, again, this is just beginning algebra. All right, so let's graph the first equation, and I'm going to color that red so we know the difference here, and I'm going to color this equation green. Now, this is standard form. We learned 3 ways to graph linear equations. Plug in a random points, find 2 random points, and connect the dots. We learned the x and y-intercept method where you find the y-intercept, where you find the y-intercept and the x-intercept and connect the dots, which is very similar to the find 2 random points. method. And then we learned the slope-intercept method, where you find the intercept and then you use rise over run to find the second point. So those are all the methods that we learned. So when you have standard form, this is standard form of an equation, because x and y are on the same side, it's best to use the x and y intercepts. So I'm going to let x equal 0, and I'm not really going to do all the math because we don't really have time. So I'm just going to write what y equals when x equals 0. And then I'm going to let y equal 0 and x equals 2. So then I'm going to plot those points. So 2, 0 would be here. So I plotted that point. And 0, negative 2/3 would be about here. And then we just connect the dots. So that's our first line. Now I'm going to plot the green equation. Now the green equation is in slope-intercept form. So I can use the intercept, which is 2. So I graph that here. And I can use the rise over run, the slope. The slope is the coefficient of x, which, as you can see, there is no coefficient up here. So it's just considered to be 1. So what that means is we go up 1 and over 2. And we just keep going up 1 and over 2. You can make as many of these dots as you want. I'm just going to make one triangle there. And then we just connect the dots. So as you can see, the solution is somewhere around here, but we can't really see exactly what the solution is. So again, this method really is not very useful because the graph is not exact. So I'm going to try to make some more points to make the graph more exact. And I'm going to make a third point. Actually, I don't really need this table because I use slope-intercept form. I'm going to make a third point on this graph. I'm going to choose x equals, we'll choose x equals negative 4, and then y would be negative 2. So let's try plotting that point. 1, 2, 3, 4, 1, 2. So it'd be right there. So there we go. That's more accurate. So you can see that this method really isn't that great of a method because you have to be really accurate. So we had to plot 3 points, and we had to plot 1, 2, 3, 4, 5, 6 points on the green line just to make it accurate enough to find the solution. And the solution, it looks like it's going to be 1, 2, 3, 4, 1, 2. So negative 4, negative 2. So again, the point of intersection, this point here, that's the solution. So what that means, I'll make that a nice big purple dot there. What that means is that x is equal to negative 4 and y is equal to negative 2 if you solve that system of equations. All right, so let's do one more of these together before you try one on your own. Let's see, I'm going to color this one red, and I'm going to color this one green, just so we can keep track. So we have standard form on the red one, so I'm going to let x equal 0, y is going to be negative 1 and 1/4, and if I let y equal 0, x is going to be 1. So 1, 0 would be here, and 0, negative 1 and 1/4 would be about here. And again, we're going to need to plot another point somewhere because this line needs to be exact. Let's see, what else can we do? We can plot, I think we can make, well, we'll worry about that later. Now let's do the green equation. So the green equation, that's in standard form also, so we're going to need to make a table for that one also, as opposed to the other green equation in the first problem, where we had slope-intercept. So let's let x equal 0, then y equals negative 5/4, and let's let y equal 0, and then x equals negative 5. So 0, negative 5/4, that's going to be about here. Ends up on the same point, it looks like. Negative 5/4 is the same thing as negative 1 and 1/4. So we can actually see the answer, and negative 5, 0, 1, 2, 3, 4, 5. That would be here. Connect the dots. So the point of intersection is 0, negative 1, and 1/4. So x equals 0 and y equals negative 1 and 1/4. That's the solution to the system of equations. Now again, it's really difficult to see by graphing. In that method, we actually didn't use graphing, we just got lucky. But if we had to use the graph alone, you can see there's no way for us to tell exactly what this point's going to be. So this method really is just unreliable. But the most important thing for you to understand is that the point of intersection is the solution to the system of equations. As long as you understand that, it's really not that important that you can do all the math on this. But I might have one of these problems on the test, so I want you to learn how to do this. So why don't you try number 17, and I'll try to leave those problems in the window, and when you come back, we'll do it together. All right, try number 18, and when you come back, we'll do it together. So that was the class today. Don't leave before I give you the homework assignment. I wrote the homework myself for this class, but before I give you that homework, this is all the work that we did today. You can go ahead and take screenshots if you want to use these pages to help you with your homework or to study for tests. All right, so now we go on to the homework. Here's the homework. I have the pages and the answers. So take a screenshot of the first two pages and a screenshot of the second two pages. And be sure to check your answers. If you get the wrong answer, go back and figure out what you did wrong. Don't just say, oh well, I got the wrong answer. Too bad, I guess I'll just go watch TV. No, go back and figure out what the correct answer is. Do your homework completely and correctly. And if you don't do the homework, remember, you're going to learn absolutely nothing in this class or in this entire course. So I'll look forward to seeing you in the next class.